Hello and welcome everybody to Hashicorp Secure. This is Daniel Drack and I'm going to tell you how to Sentinel in the real world. I'm a senior DevOps engineer at FullStackS. We're a Hashicorp partner and we regularly use Sentinel and of course Vault and Terraform in our day-to-day business. Now, today we're going to have a short look at how Terraform works in a nutshell, how policies come into play and what policies are in general, what Sentinel is, and how to use Sentinel in the real world. First, let's start with what Terraform is in a nutshell. Terraform is a tool that basically uses a desired state configuration as code translated via a provider to install and provision infrastructure in a target system via a target API. So Terraform is pretty much a universal translator for code to API. In a little bit more detail, it looks something like this. You write Terraform code in a notation in a language called HCL, Hashicorp Configuration Language, which represents a desired state, resources, and infrastructure objects. When you run Terraform plan, Terraform will go to the target API, see which infrastructure objects are already present there, and it will calculate a directed acyclic graph, meaning a plan, on which infrastructure components to create and in which order, according to which dependencies they have. Once the plan is able to be executed, we run Terraform apply, and Terraform will actually translate the plan to real-world API calls and create and provision infrastructure in the target system for you. That's how you go from desired state written in Hashicorp configuration language to real-world infrastructure provisioned by Terraform through Terraform providers, which at the end of the day are just translated packs. Now, let's make this clear with a little example. Let's have a look at this demo infrastructure. This is just a small example provisioning an SKS, which is a derivative of Kubernetes, SKS cluster with 3 nodes from security groups on the Swiss cloud provider Exascale. In practice, this looks something like this. We use Terraform Cloud in this example, which is the Hashicorp Cloud Platform version of Terraform, which brings additional features such as SSO and also the possibility to run policies against the Terraform code. But later more on that topic. Of course, we use the Terraform Exascale provider, which translates our HCL description to real-world Exascale infrastructure. And then, of course, we use the Exascale target API implicitly. The code for such a project would look something like this. We have a demo workspace containing a multitude of files, some of them having the .tf file extension, which is the Terraform configuration language files. We have some markdown files for documentation. We have a tf-var and an auto tf-var file, which contains default values for our used variables in Terraform. And then just for better readability, for example, we have an outputs tf, which will contain all the output objects, for example, kubeconfig information, SSL certificates, IP addresses, stuff like that, of the infrastructure to get provisioned. Provider is the provider config, variables contains the variable blocks, and main TF basically contains blocks like this. In our case, we're making use of our internal FullStackS SKS Terraform modules. So you can see the source references our internal module, a certain version, and some parameters for this module. This code will then be translated by an Exascale provider to Exascale infrastructure objects, specifically the cluster, the nodes, and the security groups. From the UI point of view, in Terraform Cloud, this looks something like this. We have the workspace, we have the run, and here we can see that 7 objects got created in the apply run. Now, we've seen a little demo of how Terraform works and how and what it actually consists of. Now we're going to have a look at what policies are, and in the next steps, we're going to see how Terraform and policies can play together to create more high quality infrastructure provisions and how to increase quality of your internal infrastructure landscape. Let's start off with what policies are in general. Policies are guidelines or rules established by organizations, by governments, or other entities to direct decisions and achieve rational outcomes. They serve as a framework for consistent and efficient decision making across different situations, and they help us to ensure compliance with standards, laws, and regulations. They typically develop to address specific objects and to guide the actions of those within the organization or society to achieve desired results. That's a very, very general definition of what policies are. To make this a little bit more tangible, let's have a look at organizational policies and the kind of a pyramid scheme from low-level policies to technical policy as code policies. Let's start off with the bottom layer. That's what we call organization policies. Organization policies are pretty much a collection of public and internal policies affecting the organization. Think of laws, for example. Laws are just policies at the end of the day restricting or allowing certain actions. Maybe also think of certain code of conduct, social policies, for example, environmental policies, policies affecting public opinion, PR towards your organization, stuff like that. The next layer are organization standards. These are internal standards and procedures trying to fulfill organization policy requirements. The goal or the aim of organization standards is to standardize procedures, processes, etc., to have a more streamlined organization and a more efficient organization. So they do not specifically derive from organizational policies, but they should adhere to them, be compliant with them. So for example, if you're an automotive manufacturer, you might come up with a very innovative new way of creating cars or car parts, which might be very nice in terms of being a standardized and fluent way of running through your several process steps. But you also need to make sure that you're compliant with your organizational policies. So for example, you need to be compliant with laws regarding environmental sustainability, stuff like that. That's the difference between the standards and the policy. The next thing is GRC, which stands for Governance, Risk and Compliance Controls. GRC controls are a set of controls aimed at checking and implementing org policy requirements. These are your typical GRC frameworks. These frameworks typically contain strictly formulated controls that you can check against. This is what you usually have at hand when you have an internal or external audit, for example, if you have an ISO audit or stuff like that. This is where GRC controls come into play. Also, enterprise architecture frameworks, COVID, for example, they heavily work with controls. And depending on the nature of a control, you can then derive policy as code or as code policy from that. PAC policies stands for policy as code. These are purely technical policies that allow you to check and enforce certain circumstances in your organization. For example, the GRC control could say something like, you need to make sure that each user has the least necessary privileges assigned to their user account, but least privilege is hard to validate and hard to technically check. But for example, a GRC control could also say you need to enforce multi-factor authentication for each and every user account. That's something you can check quite well technically. Therefore, you could derive policy as code control for that. That's also why policy as code policies and checks are at the very top of the pyramid, because you can create policies and controls for lots of things, but for most things it's actually quite hard to formulate them technically and to make them tangible and graspable. Now, generally speaking, if we implement policy as code, we usually have some kind of event, change in legislation, or maybe a nature catastrophe, some social events, occurrences, stuff like that, Some event that results in having a change or that results in the need of a policy change or in the need to create a new policy. So for example, if we have a code of conduct violation, we might need to come up with a policy stating how to behave on social events at our company. For example, if the law changes and sustainability goals change and environmental laws change, we might have to adapt our internal policy documents. Policy documents usually are some kind of prose documents, so Office documents, Word files, stuff like that, PDFs. So documents that depict certain behaviors, certain rules, certain controls probably to also check the policy goals, but they're usually formulated as text, as prose. The important or the interesting part for us here is how to translate a policy document to code. This is actually a manual step. It's nothing we can automate. This is something we need to have a look at item by item, control by control, and decide if and how we can translate a prose document to code. Code, for example, can be Sentinel code, something we're going to look at in a minute. So code actually means the technical representative via a policy as code tool. Yeah. Now, speaking of policies and speaking of Hashicorp, we need to talk about Sentinel. Just to give you a little introduction about what Sentinel actually is, Sentinel is an embedded policy as code framework that enables fine-grained, logic-based policy decisions that can be extended to source external information to make decisions as well. The important part here is policy as code and embedded. For the Hashicorp stack, this means that Sentinel and the Sentinel policy language can be used in different products across different layers of the infrastructure. For example, we can use Sentinel in Terraform. Between the plan and the apply step, we can apply certain policies on the created plan, for example, but also on the existing state or the current configuration. We can use Sentinel policies with Vault to extend Vault's access control list feature, and also in front of all the Vault APIs to enable fine-grained access control. Same applies to Consul. We can also use Sentinel to extend Consul's access control list features, and we can use it in front of Consul's key value store and other service APIs. And Sentinel is also baked in with Nomad. So we can as well use it for Nomad's access control list system, and we can also use it to ensure that only compliant new jobs or existing jobs can be updated. So we can actually enforce the content of workloads run on Nomad. Now, this talk is about how to use Sentinel in conjunction with Terraform. Let me tell you, Sentinel loves Terraform. The usual way of doing things with Terraform and with Sentinel looks something like this. We have a source code management system on the very left-hand side. We have a code change. This triggers a plan and apply run, for example, in Terraform Cloud or Terraform Enterprise, since the baked-in version of Sentinel is an enterprise feature. Terraform Cloud would then run the plan, create the plan JSON. This is then where Sentinel kicks in. Sentinel can check the plan, the state, the configuration, and the run information. If the Sentinel policy, the result of the plan is compliant with the policies formulated in Sentinel, we can head on to the apply stage, the apply step. If the policies, however, don't fit and the plan is not compliant, the apply run can be stopped. But this is actually some kind of a gatekeeper to keep malicious code changes or maybe just unintended code changes from going to production if they're not compliant with our policies. As I mentioned before, Sentinel can work with 4 Terraform entities. We can use the Terraform state, which represents the already existing infrastructure, to make decisions for the next change. So for example, we could make policies based on what is already there. For example, that we do not want to shrink databases, for example. So we do not allow to shrink an existing database. That's what we probably need the Terraform state for. We can also use the Terraform plan, of course, to restrict which new or infrastructure can be provided or which changes can be applied to the existing infrastructure. We can use the run information, which is actually quite interesting because, for example, Terraform Cloud and Terraform Enterprise, they come with a feature of cost estimation. Cost estimation is part of the run information. So we could also build, for example, policies based on what the new infrastructure will cost us. And the last thing, of course, we can also check and apply policies to is the Terraform config, which is actually the HCL code. But also stuff like, for example, use Terraform provider versions, authentication methods, stuff like that. We can apply Terraform Sentinel policies to each of those entities. All right, let's dig into Sentinel in the real world. This is how it's done. Now, first some basics. Sentinel, if you use it locally, is actually a small binary CLI tool, which you will need to actually develop and build new policies. Sentinel is a dedicated language, so this is not HCL, but Sentinel policies are actually formulated in Sentinel language, which is a dedicated language, although it looks quite similar to HCL. We're usually dealing with three kinds of file names. We're dealing with .sentinel files, which actually contains the policies or the checks, .hcl or the JSON files, which are more of the metadata files. More to that in a minute. And Sentinel makes heavy use of mocks and tests. So this is a very, very test-reliant and test-driven technology. And it's also baked into Terraform Cloud, into Terraform Enterprise, since we even have a download mock data and test data button after each plan. So much for the basics. Now, let's dive into this with a simple real-world situation. On the left-hand side, we have our developer who's called Bob, and Bob wants to do some testing for his new application. Therefore, he wants to use the self-service portal and the Terraform Cloud portal of his company to provision a new virtual machine on exascale, as we've seen before. Since in his mind, this application is quite strong and big, he needs a big machine of type standard large. Bob will make this change or create a new workspace with this HCL, with this Terraform code, and will try to apply it and actually create it in exascale. But the organization policy states that self-service virtual machines on exascale must not have a type other than standard micro. Maybe that's a finance-based decision. We don't know. But that's what the policy says. So there we have contradiction. The policy code of the company restricting certain sizes of the exascale EVM might actually look something like this. This is real Sentinel code. As you can see, it's actually quite straightforward. We're making use of an import function. We're making use of planned functions, which is a pre-existing set of predefined functions that we can just use out of the box. We defined an array of allowed instances, which in our case only contains the standard micro instance. We then get all VMs from plan. So this would actually run after Terraform plan. We're making use of the created plan JSON. We're getting all VMs. We filter the list of all VMs for those that are not of type standard micro, which we call the bad VMs. And then we check that this list should actually be 0. We don't want to have any bad VMs. And if it is not 0, then the rule is violated and the policy will go red. In the real world, Bob's experience will look something like this. In Terraform Cloud or Terraform Enterprise, Bob will create a workspace. He will start his plan. Cost estimation is finished. In that case, there is no cost estimation since this is not supported for exascale. But the policies are run against the created plan. And as you can see here, we have a failed policy that tells Bob that his intention to create a standard large VM is actually restricted by these policies, and that the only allowed policy would be a standard micro. But this is actually a useful error message that will help Bob alter his HCL file to be compliant with the policy. One more thing that we can see here is that we actually have 3 policy modes with Sentinel. We have advisory, which is just an information that would hypothetically tell you that your desired infrastructure is not compliant with the policy, but since it's on advisory, it's on information, it will not stop you from hit the apply button and actually create the infrastructure. The next policy mode is called soft mandatory. This actually means that your run will be blocked, but depending on which user rights you have in Terraform Cloud, Terraform Enterprise, you might have the right to override the decision of the policy blocking you from hitting the apply button, which is usually not the case for developers. This right is usually reserved for either somebody up a little bit up in the hierarchy or for administrators. But more to that in a minute. And there's a third mode called hard mandatory. This will actually be a hard cut and stop the whole Terraform run from even giving you the opportunity to override apply. So there is no way, if this is a hard mandatory policy, that you can override it. This is really a hard cut. All right, let's talk about a minute about a real world setup in terms of how we usually see Terraform being used, which entities are in this ecosystem, used in this ecosystem, and how Sentinel comes into play. We've already heard about organization policies. This is something that should already be in place. If you're a platform engineer, DevSecOps engineer, something like that, you should not come up with organization policies. This is something that has to be provided from the very department. Coming or translating these organization policies into code, that's what we do with Sentinel. And the result of that are actual policy or Sentinel rules. That's what we've seen before with the bad VMs, bad VM rule or the exascale VM policy, restricting the creation of bad VMs. The next entity is quite interesting, as you usually don't want to apply individual rules or single checks of policies, but you rather would like to have policy sets, which at the end of the day are just a bundle of checks or rules bundled together on a certain name and deployed together. Think of it as something like a configuration bundle. This is actually also what you import and then use and configure in Terraform Cloud. The next thing we always see and hopefully always have is some kind of governance and responsibility. This means that the person that actually wants to create infrastructure shouldn't be the same person that also has the right to override a failing policy. So we want some kind of segregation of duties, some kind of governance and responsibility there. This is a hierarchical topic. But this is nothing technical, although it is represented via hierarchies, groups, policies, rules, etc. But in the first place, this is a management organizational chart issue. The next entity or thing we see is a source code management system where we actually keep all the configuration, the code, the HC files, etc. And then, of course, Terraform Enterprise or Terraform Cloud, where we actually make use of the files and where we execute the Terraform plan and apply runs, Sentinel execution, and so on. These are usually the 6 entities we see in the wild. Coming back to the Sentinel rules and to policy sets. Again, this is what a Sentinel rule looks like, for example, for the exascale VM. And as you can see, this is one rule with a lot of comments and a lot of explanation, but this only deals with one scenario. This only sees and checks if we use VMs of a certain type. This does not check if we use certain CPU types, if we use a certain size of memory whatsoever. This whole policy only checks for the type field of the VM. And that's good. This is a very well written single purpose policy. But as it might get hard to maintain a lot of single purpose policies, that's where policy sets come into play. Now, as you can see, this is a workspace containing a policy set. And the policy set is actually an HCL file, as I said before. This is just a metadata file at the end of the day, and it contains modules and policies. And in the policy field, we can actually see the source, which at the end of the day is the Sentinel file, which contains the rule, and we see the enforcement level of soft mandatory. The interesting part is we can also have different enforcement levels for different rules in one policy set. And of course, policy set are also maintained as code in a certain Git repository. Now, if you want to use a policy set in Terraform Cloud or Terraform Enterprise, you go to the settings, go to policy sets. You already need to be connected with your source code provider, but it's actually quite easy, so I'm not going to show that here. Then you browse to the repository, and then you select the HCL file, the policy set file. And the interesting part is here, you can see the field that says scope of policy. In that case, we only enforce this dedicated policy set to certain projects and workspaces, but you should definitely also have certain baseline policy set enforced for all workspaces globally. Now, 2 more minutes about what lessons we learned in the field. I'm going to go through the 6 entities we already know and tell you what we learned in the previous years. First, organization policies. This is a segregation of duty prime example. If you're the guy that implements DevSecOps or if you're a platform team member whatsoever, you want to have your policies predefined by somebody else. Not the as code policies, but the organizational policies, the pros text. You should or you must not define these on your own. Somebody else needs to define that. We as engineers, we just need to translate it to policy as code. And for that, we need tangible controls. We need graspable, tangible controls that we can actually formulate as code. This is also something we need to demand from the organization policy document. The next thing is about the Sentinel policies or the rules. Probably the most important part is this is complicated. It's not easy out of the box stuff. You need to make yourself familiar with Terraform, and you need to make yourself familiar with Sentinel and with the Sentinel language. Have some dedicated stuff. Somebody who knows this field, somebody who knows how to write policies quickly. If you do, have workshops with the dedicated service owner and platform teams. Go through Terraform plans, see how their service is used, and then see which policies apply and how you can actually translate them to code. What we usually do is we really have a look at the plan output, the JSON files with our customer, and for each field, we then try to see if we can find a policy that restricts the usage of this field, and for that, we write policies. And for that, we have some dedicated team member that is quick and good with writing Sentinel code and also makes use of mock and test data. This is something that really comes out of the box with Terraform Cloud. So once you do a plan run, there is even a button that says download your mock data. So this actually comes out of the box. Make use of it. And if you write test case, always write a passing and a failing test so that you can test both sides. The next thing is about policy sets. As I already mentioned, always try to have a global policy set in place that is kind of the organizational baseline. In the policy set, try to work with the soft mandatory field or enforcement level as much as possible. Soft mandatory because you don't want to use hard mandatory, because if you need the opportunity to override something and you don't have it at all, this is something that will cause problems, because there will be a situation where you need to override a policy. If somebody needs to go quick, you need to deploy something, you need to at least have the possibility to override it. And if you introduce new beta policies, start with advisory so that they don't block in the first few days, and then switch them to soft mandatory. And as I said, if you have a global baseline policy set, try to have domain-specific policy sets that are more restrictive but aimed at certain teams, products, whatsoever, if applicable. The next thing is about governance and responsibility. Technically speaking, governance is a management responsibility. Rely on predefined organizational hierarchies, rely on pre-existing processes. That's something not an engineer should decide or should be heavily involved with. That's a management topic. And from a design point of view, give your engineers and your users the possibility to do pretty much everything in Terraform Cloud, Terraform Enterprise, except overriding policies, altering variable sets. But let your people create workspaces, infrastructure, etc. But have your policy in place to prevent situations that you don't want to have. Next thing is source code management. Of course, maintain a very strict access control for your policy repos. So know your role-based access control. If possible, maybe also use code owners, if that's useful, to finally restrict the access to certain files. So for example, you might have a big policy repository, but team A should be able to alter certain policies, and team B should only be able to alter certain policies. That's something you could do with code owners files, for example. Always use an inner source strategy, so let everybody read the policies. So kind of inner source for organization, everybody should be able to read, but only a very small amount of people should actually be able to alter the policies. And treat your policies as code, because they are. Apply your development flow, use a branching and a tagging strategy. Finally, we have Terraform Enterprise, Terraform Cloud. Same applies here. Know your role-based access control. Try to manage all the roles via SSO and groups. So try to outsource that to your internal identity provider system, and try to do as little as possible in Terraform itself. And also try to introduce, as I already mentioned, new policies as advisory state and move them to soft mandatory after some days. Have one team actually manage policy sets, so that's also nothing you want to have shared responsibility, but have clearly cut roles and clearly cut teams for this topic. And as always, release often, communicate clearly. That's actually what we learned about Sentinel and how to use it with Terraform. Thank you. I'm Drack from FullStackS.